Hi, everybody. This is a video lesson for our Light Waves unit, lesson 3.5. Just as always, I just want to remind you, these videos are intended for you to pause throughout and complete the activities as I show them to you. So if we go over here to classwork, we can see our lesson here. We can see our key concepts, and we can also see our login. Now, we don't have any new key concepts to um, introduce. I do want to very quickly, before we start this lesson, cover a key idea, a key concept that I think everyone needs to know. And it's right here, friends. So remember, light can do one of three things when it interacts or doesn't interact with a material, right? It can be absorbed, and in that case, we will see a change because it's taking in energy. It can also be reflected, and in that case, the light just bounces off and we don't see a change when there's reflection occurring. And then also, same thing with transmission, which is where the light just goes right through that material like it's not even there. That's all I wanted to share with you on our key concepts for now. Let's go ahead and click this button and log into Amplify. Okay, so here we are in our warm-up, and what we're investigating is really the atmosphere. And going back to our key questions from that are kind of driving our investigation is, we're still focusing on Australia. We're trying to figure out why skin cancer rates are so high there. And we're narrowing it down now to maybe there's something different with Australia's atmosphere. Because remember when we compared Australia and Brazil, um, Australia and Brazil get about the same amount of sunlight, but Australia gets a ton more ultraviolet light. So we're going to investigate that here. So here's kind of an example of what we're talking about. In the air, there's all sorts of things. There's gases and particulates and droplets just floating around up there. And those all have the potential to interact with light. So what I'd like you to do is I'd like you to read this statement over on the right here. And then I'd like you to answer this question. What are some things that might happen to light when it hits different materials on its way through the atmosphere? I'll give you a hint. If you rewind this video 2 minutes, I showed you a slide at the beginning that shows you 3 things that could possibly happen. Go ahead and put your thinking down, push that hand in button, and then let's go on to the next slide. So go ahead and pause, answer the question, push hand in, and let's go to our next portion. So friends, for this part, I am going to pull out my little cheat sheet here. So what we're doing today is a little different. Let me move my face if I can here. Yeah, there we go. All right, so we're going to be using the sim in our activity, but as I said before, based on how you did in your critical juncture in our previous lesson, it will put you basically in a group. And so you're either going to be in the ozone group, which is right over here, the sulfuric acid droplets group, or the carbon dioxide group. And let's dive in. So there's going to be a green, a purple, and a blue group. And depending on what color you are, that's what you're going to be investigating. Now, I'm going to start off supporting the blue group, and then I'm going to go to purple. And green, I'm not going to go through yours very much at all. I think you guys will be good to go. So if you're not in the blue group, then go ahead and skip ahead just a little bit. Blue group, stay with me, though. All right. So, my blue group friends, you have a prediction to make before we go any further. Okay, you're going to make a prediction that ultraviolet light will cause damage to either all materials, to some materials but not others, and then will only cause damage to genetic materials. So go ahead and make that prediction. You're just taking a guess. What do you think? And then we're going to go and we're going to test that. So hopefully you've made that prediction. And what we're going to be doing is we're going to be using the laser, and we're going to be using ultraviolet light. And we're going to be testing the following materials: genetic material, glass, aluminum, sunscreen, and carbon dioxide. And as we do that, we are going to answer these questions. So I think we should kind of go in this order where we go genetic material. And you'll see these are drop-down boxes. So genetic material, light is what? Absorbed, reflected, or transmitted. And what's the effect going to be? Is it going to be change, warmth, or damage? And then the energy was absorbed, energy was carried by light. Okay, so we're going to go through the sim. We're going to test that. And so we are going to do genetic material with our laser set to UV light. So let's do it. And we're here. Laser, check. Ultraviolet. Nope, not just violet. Nope. There it is, ultraviolet. Let's make sure it works. Woohoo, it works. So now we've got to get our things from down here. And, oh rats, I already forgot what was first. Genetic material? Yeah, genetic material. So that would be this little double helix guy. We can turn it on. Let's turn on our energy beam too. Ooh, that looks like it's absorbing. It's not bouncing off and it's not transmitting through. And there's damage that's occurring. So let's see if we can answer some of this. Light is absorbed. The effect was damage. Energy was absorbed. Okay, so now it looks like it's time for us to do that same thing, but with glass. So let's just bounce over here to this other screen, and let's get rid of that, and we've got to do glass now. Oh, interesting. Look, you guys, it's not even going through the glass. It's absorbing it, it looks like, and it's warming it up. Interesting. Okay, so now we can answer these questions, right? So what happened to the light? Light is absorbed, right? And then we've got warmth as a result because it was absorbed. And then the energy was absorbed. Absolutely. Let's do aluminum next. So let's get rid of the glass. Let's throw some aluminum up there. Oh, interesting. Look at that. So we've got, when it bounces off, that's called reflecting or reflection. So the light is reflected. There was no change. And the energy was just carried with light. It just continued on. Ultraviolet, ultraviolet, no change. Awesome. Okay, let's go to sunscreen and then carbon dioxide. So, sunscreen. Why can't I find the sunscreen? Hey, friends, I had to open up another one, as you can see here. So I had to open up another window because I couldn't get to my hamburger in my upper left corner here. And I got to turn this to complex, load complex mode. Yes. That way I can get to my sunscreen. Okay, there's my big pile of sunscreen. I got to reset my laser. And I like to show the energy too when I do that. Okay, what do we got? Oh yeah, look at that. Sunscreen, it is getting damaged. It's absorbing. So now we can answer what's going to happen for our sunscreen. Light is absorbed. The effect was damage. And the energy was absorbed. Last but not least, friends, we've got to do some carbon dioxide. So I'm going to drag that one down. And where's my carbon dioxide? Hey, there we go. Wait, is that really carbon dioxide? Oh, it is. Look. It's not doing anything. It's transmitting through. This is the first one we have that transmits through. And notice there's no effect, no change. So, cool. Got our transmitted. We've got no change. And then since it wasn't absorbed, the energy was just carried by light. So for this question, I'd like you to answer this one on your own, which was your prediction correct, and explain. For this one, when light is transmitted or released, is any energy, or I'm sorry, when light is transmitted or reflected, is any light absorbed? That is a yes or no question. You're going to answer that one on your own. And then how can you tell? So that has to do with this. Okay, so this is a big check for understanding. By now, we should know what happens when light is transmitted or reflected. So try your hardest to answer that question. And let's see here. Oh, this is my, this is part 2. And it's very similar to what we just did. So the first thing you're going to do is you're going to make a prediction. There's different types of light will all interact with ozone the same way because all light is the same. Different types of light will interact with ozone. So friends, let's go ahead and make that prediction right now. And then we are going to go through and do some testing. And what we're going to be testing is we're going to be in our light waves. We're going to be dragging the ozone molecule from platform 1 into the testing area. We're going to use sun, and then we're going to tap the beam to inspect. And we are going to test all of these frequencies of light on ozone now. So let's do that. Let's get rid of that. Where is my ozone? Triple oxygen molecule. And let's see, we've got to turn that to sun though. So what do we got? This is everything that we're testing. What's coming out on the other side? So only visible light and radio light is going through. Everything else is being absorbed. And let's inspect. And we're seeing 2 kinds of change. We're seeing damage and increased kinetic energy. So just like that, with that quick little setup here, we've got it all figured out. So let's see. Gamma rays. Those, I got to go back and look. Oh, those were absorbed. My bad. Absorbed. There's the ultraviolet light. Yes. Everything but radio and visible. So the visible light was transmitted. And the radio light was transmitted. Everything else was absorbed. There we go. Based on your investigation, could the amount of ozone in the atmosphere be a factor why Australia gets more UV light than other parts of the world? Yes? No? Maybe? Go ahead and pick one of those. I would say yes. But please explain your answer. Based on your investigation, do all types of light interact with materials in the same way? Yes? No? And then explain your answer. All right, so I'm going to go back just really quickly because I want to make sure that this other group, my purple group, knows what's up. So you're making a prediction and you are testing these light waves right here, but you're going to be doing the sulfuric acid droplet instead. Okay. And then when you get over to here, you are just answering those questions. So blue and green groups, you guys have a little bit less to do. Part 3. So friends, I'd like to go through our findings. So if you look at this figure here, you'll see we've got ozone, we've got acid, and we've got carbon dioxide. That's what these little molecules here represent. And we've got ultraviolet light coming down, interacting with those 3 materials. And what we've found between all 3 of our groups, depending on which one you were in, if you were the ozone, sulfuric acid, or carbon dioxide group, here's our conclusions. Ozone absorbs ultraviolet light. Sulfuric acid reflects ultraviolet light, and carbon dioxide transmits ultraviolet light. So I want to ask you a question right now before we end this lesson. Which would you rather have in your atmosphere to protect you from ultraviolet radiation? And friends, we are skipping the homework section. Make sure that you have, in part 2, make sure that you have pushed that hand in button on the last slide here. This little hand in button. Let's make sure that we get that done. And good job. Let's end this lesson.